Good morning. Happy Memorial Day. Just finished looking at the exams, reviewing them. Very good. Y'all did very well on the exams. Several hundreds, a lot of A's, so that's excellent. I'm very happy about that. Um, One thing that is always a trouble area, but wasn't big trouble, just here and there, were the conversions. When you're converting from a prefix to a different prefix or from a number to a prefix, it's all about the power of 10 you start with and the power of 10 you're going to. So if you're starting with 10 to the negative 2 and you're going to micro, which is 10 to the negative 6, well, you have to subtract 4. Okay, because negative 6 is 4 smaller than negative 2. So therefore, you have to move the decimal point in your number 4 places to the right. What y'all did was you moved it 4 places to the left if you missed those. So you moved the decimal in the wrong direction. So remember, when converting, okay, you are doing the opposite. So if you add to the exponent, you move the decimal left. If you subtract the exponent, you move the decimal right. Okay. Now that you're not going to be doing a whole lot of converting, but you are going to be needing to work with these prefixes. Okay, and I'll talk about that here shortly. But everything else in exam 1 was great. Moving on into exam 2. And again, for those y'all that are doing very well, don't rest on your laurels, because I've seen people fail the final that have made hundreds on exam 1 and A's on exam 2 and 3. So make sure you're, all the time you're doing this, preparing yourself for a proctored final where you're getting notes. You get a page front and back in notes, but you don't get books and apps and things like that. Those apps are really great, but they should be used to learn, not just to get an answer. Okay, so that's all I'm going to say about that. But as we move on to exam 2, circuits do give students trouble, especially if you're not in the electricity, electronics, industrial maintenance programs where you're familiar with, what a circuit is. But you can still do the math. So we kind of start out with a little trigonometry, some complex numbers, things like that. Know how to work the trigonometry and the Pythagorean theorem. Make sure you're using the correct trig equation. In other words, you can't always use sine. All right. The steps are, you choose an angle of reference, whether it be whatever, theta, phi, A, B, C, whatever, and 2 other sides. So you get a combination to where you have one unknown. Once you choose the angle of reference and the 2 sides you're going to look at, then you choose your trig equation, substitute what you know, and solve for what you don't. Okay, so, watch the videos, look at the examples, and kind of see how to work things. Now, I cross multiply oftentimes when I do use these trig equations. Some of the videos, they do it differently. It's just all about solving skills here. Okay, it's trigonometry is about solving, is about using the correct trig equation and round to 4 decimal places until you get to your final answer, or your final answers are all going to be off just enough to where the computer's going to count them wrong. Okay, so practice that. Get good with knowing when to use sine, cosine, tangent. It's not impossible. I've taught this course on campus for years, and it's obviously a little easier on campus because I'm sitting there helping and showing examples, but I really never have had students, do poorly in this class that have come and have done what they're supposed to do. So you can do the trig. All right. Now, when you get into the circuits, oftentimes in the problem sets, they give you a circuit as it would appear in which quadrant on a graph. Okay. So for RC circuits, they're down here in the 3rd quadrant. RL circuits, they're in the 1st quadrant. Don't try to worry about the way it looks. Use these triangles, okay, that I've supplied to you in my RC and RL Circuits video. It's the last video under the RC Circuits video set, where I show you examples using these triangles. So these top two triangles are the RC circuits. The bottom two are the RL circuits. And you can see they are different because, the RC, let's see if I can do this. That's third quadrant. If you think about V sub R being your x-axis, V sub C goes down. Okay, so it's in the third quadrant. RL, V sub R again is your x-axis, but then V sub L goes up. So that's in the first quadrant. They are different, so make sure you draw them correctly. Okay, V sub C is negative, X sub C is negative. Okay, theta is negative in the RC circuits. All right, so just use those triangles and write down what you know and solve for what you don't. Don't worry about what it looks like. Okay, the other issue is finding X sub C. And I show that in that video as well. So please watch those videos. Now again, some of them are mine. Some of them are the other people that created this class. So if you like my videos, then just click on the video and you'll know my voice. Okay, because I think the other voice may either be female, which definitely doesn't sound like me, or a very soft-spoken male voice, which again is definitely not me. I am loud. So you'll know. Or watch all of them. But I'm telling you, you can do this if you just work at it. All right. When you use finding these measurements, you have to convert the prefix to a raw number. So in other words, oftentimes you're going to be given data for some of these triangles, and it may say we have 3.6 K ohms. Well, when you're doing your calculations, especially with your trigonometry, and if you're finding other sides, you have to do 3,600 ohms. It's mainly in the X sub C, X sub L formulas, but you have to use that because, see, if you get X sub C wrong or X sub L wrong, everything else is going to be wrong because that's the first side you're finding. So get good at using those formulas. The X sub C formula is more difficult than the X sub L just by the way it's set up. But again, I show you what I think is a good way to do this to help you out to get the answer correctly. So please watch the videos. Watch the videos. All right. So, and as always, ask me for questions if you have any. I'll do the best I can over email. Get to work. Time flies. When you do the polar coordinate conversion, that's difficult. That's probably the hardest thing you're going to do this section. You have to get to the rectangular coordinates and then add or subtract and then convert back to polar. So it's a lot of work. I've got examples on that as well, or a video on that as well, I believe. Watch them. Watch the videos. You may have to for this section. You may not have to for the last test, but for this one you probably will. Frequency. I mean, when you get to angular velocity, please, these are not, something goes on where people miss these because all you're doing is taking the number you get either times 360 or times 6.28, 2 pi. Don't make it harder than it is, okay? If it's angular velocity in radians, it's 2 pi times the frequency. If it's angular velocity in degrees, it's 360 times the frequency. I mean, that's just multiplying two numbers. So something goes on with students that I've seen, they miss all those. And so whatever it is, try not to. All right, enough's enough. Almost 10 minutes. I've talked way longer than I need to. I've got work to do. I got to go out and work on my deck. So I'm going to go out and sweat. But I wanted to at least touch base with you on this stuff. Good luck. Don't be afraid, but I want you to be focused. Okay, and have a great Memorial Day.